Hey guys, today we're going to learn about inverse trigonometry. And so we're going to look at specific functions and take their inverses. So let's start with sine. In fact, this whole packet I'm going to do with you guys with sine, and then we'll look at, I'll let you look at cosine and tangent and others on your own. Alright, so first I just want to graph sine. Okay, I find it easiest to graph points first and then connect the dots. So we got all these points and we connect it all and we have sine. Alright, now just a reminder about what inverse is. It's switching the input and the output. Okay, so in this case, when we have sine of x, the input is an angle and the output is a ratio, and we're going to switch those two when we talk about inverse. Okay, so if we have f of x, remember that f inverse of f of x equals x is one way to look at it. That black dotted line you see there, that's the y equals x line. Remember that switching y and x is another way of thinking of switching input and output. And graphically, we're just going to reflect any inverse over that line. Okay, so when we reflect it, let me plot a few points here, doing the same thing I did before, and I'm just switching each of the points I drew there is the same as one of the previous points I drew. We just switched the x and y, and when I connect the dots, we get something like this. Now, there's a problem with this. The problem is that the inverse of the sine function is not itself a function. You can look at it because it doesn't pass the vertical line test. And you would have known that ahead of time because you knew that sine of x does not pass the horizontal line test. So when you reflect it over y equals x, its reflection does not pass the vertical line test. However, you see those two purple lines I threw in there. If we do that and cut off everything else other than what's between those two lines, well, that little part would pass the vertical line test. And if you go back to remembering what we did with inverse functions, a lot of times we had to restrict the domain. So in this case, we're cutting out all the top and all the bottom, and we're going to say, hey, let's just look at that part in the middle there. Okay, and yeah, we're going to have to restrict the red domain so we can only get the purple, because that little part in the middle, the purple, actually is a function. Now the way you do that is you cut off the red there and there. Okay, so I took those and I reflected them over the y equals x line. You get that. What it ends up being is that we restrict the domain to being between negative pi over 2 and pi over 2. Okay, now so it looks something like that, and you notice I did put the or equal to because we do want to hit those points, right? That's at -1 and +1 respectively. And so that thing on the inside there is a function. Okay, so we restrict the domain. Now that's only for sine, right? You tangent and cosine will probably look a little bit different, and I'll let you think about that when you get to those at the end of the packet here. Just so you know, the range goes from -1 to +1, and remember when you have an inverse, these guys are going to switch places because we're switching our x and y. So the domain of sine of x is going to become the range, and the range of sine of x is going to become the domain when we switch them. Okay, so let's look at the official definition then. Now that you've built up some intuition, so the inverse of sine, and another way to write that is arc sine. You'll see that in Desmos, although Desmos being awesome, both those work. And yeah, that is the inverse of sine on the interval from negative pi over 2 to pi over 2, including the ends. All right. So let's just draw that. Or let me put one caveat before we draw that. Remember, f to the -1 of x. That's how we write the inverse. That's not the same as a -1 power. Okay, we call that a reciprocal. So remember, a reciprocal is when you do 1 over something. So with sine, the same is true. You won't see this one on the right here. You won't see that too much. But yeah, just watch out for that. Make sure you're writing it like this, and that means the inverse function. Okay. So I'm going to draw those 2 points. That's sine of x there, and that goes from negative pi over 2 to pi over 2, and yeah, we're just going to reflect it, and it looks something like that. Now, I kind of wish I'd blown up this graph and drawn it a little bigger. You guys can graph this on Desmos and look at it so you get a better idea of what it looks like on the graph. Okay, I want you guys to sketch the cosine inverse and the domain restrictions before class, okay? Now, just a note, the domain restrictions are not the same, so don't do from negative pi over 2 to pi over 2, because you'll find out that's not a function. And yeah, I want you guys to see that before coming to class. So go ahead and do that now, pause the video, and finish that. Thanks. So now that you've graphed cosine inverse, we're now going to look at some problems with these. One of the things I want you to know is that now the input is a ratio and the output is an angle. Okay, those two things, remember, that switches. So what's that going to look like? Well, if we're finding sine inverse of root 2 over 2, okay, I'm going to use this unit circle over here now. I'm going to remind you guys, on the unit circle, the points x comma y, that relates to, or is equal to, cosine of the angle, and y is equal to sine of the angle. So when I'm looking around here, I'm just seeing cosine theta, sine theta, okay? So let's do this first one, sine inverse of root 2 over 2. I want to find root 2 over 2 on the y, because that is sine, right? So I'm looking, I see it right there. Cool. That means that if our input is a ratio, the output is the angle is just pi over 4 there. So that equals pi over 4. Now, yeah, you could also write down 45 degrees. Either one of those is acceptable on a quiz. You should recognize that both of those are correct. And I want to point out something else, though. If you look over there, do you see how the y is root 2 over 2? And that's a different angle, right? So how do we know which one to pick? Well, the thing you have to know is that this guy is not in our domain, okay? Remember we said, oh, we can only go from negative pi over 2 all the way to pi over 2. That's bigger than pi over 2, so it's outside the domain of the function, of the inverse sine function. So you don't worry about that one. A general rule of thumb would be you look in the first quadrant first, so the top right, and if it's not there, then look in the second or fourth quadrant. You typically, or you'll never find an inverse of sine or cosine in that third quadrant. So I'm just going to kind of exit out here, okay? Yeah, that's kind of rule of thumb. Hopefully you found the correct domain for cosine, and you understand why it is we don't look there. Alright, so speaking of cosine, let's try cosine right here. We have the input is now negative 1/2, okay, so that's the ratio. So I'm looking around the circle, looking at the x values this time, because that is cosine, right? And I'm looking for negative 1/2. Let's see. Oh, we found it right there, okay? These guys, oops, I already circled them. So if negative 1/2 is the input, the output is the angle, which is just 2 pi over 3. Again, you could also write 120 degrees, all right? Yeah, for the next one, tangent, that's the trickiest, because you have cosine and sine there on the circle. You don't have tangent. You just have to remember that tangent is sine over cosine, all right? So what we're looking for when we're looking at inverse tangent being 1, we're saying, hey, when are the ratios of sine and cosine? When are they equal? When are they the same? And if you look around the circle, it's right there, root 2 over 2, comma root 2 over 2. That's when they're the same. So the angle's, again, pi over 4, aka 45 degrees. I want you to try these other 3 problems right now while this is fresh in your mind. And so pause the video, and yeah, we'll check and make sure you got these correct in class. Alright, moving on. This is the trickiest part of this unit, or this topic. What we're going to do is we're going to do a function composition. That means one function's inside the other, and one of these will always be an inverse. So you see we have tangent inverse of a ratio, and the outside of the function is cosine, okay? First thing you want to do on these is draw a triangle if it's not already drawn. I already got one drawn here for you. And I want you to label an angle theta. Now, I know that angle is going to look a little bit better in the future. It doesn't really matter which angle you label, because you're going to be putting the values in. And so what I want to do with this angle is, if I know that tangent inverse of 5 over 12 is an angle, I'm just going to say, hey, let's make that angle theta, because remember, your input is now a ratio and your output is an angle. Another way to think about this, if I write it the other way, it's tangent of theta equals 5 over 12. Those two expressions mean the same thing, right? We just did the inverse on one of them. So if tangent of theta is 5 over 12, that means opposite over adjacent, so kotoa, opposite over adjacent is 5 over 12. So I'm just going to label those sides 5 and 12. Okay? It's really, really important that you draw a triangle for these problems because you need to usually find the third side. We can find the third side using the Pythagorean theorem. So a squared plus b squared equals c squared. And I'll let you guys do that. You get 13 when you do that. So now I know all three sides, so I can do any of the 6 trigonometric functions. Let's look then at cosine of that tangent inverse of 5 over 12. Well, if tangent inverse of 5 over 12 is theta, then cosine of that big ugly mess is the same as cosine of theta, right? Because I just said up here that they're equal. So we have cosine of theta, and this is like a super easy problem now because you guys know your SOHCAHTOA. Cosine is adjacent over hypotenuse, so you get 12 over, whoops, that's a righto, 12 over 13. Okay? Alright, so yeah, I want you to try this next one here on your own. Do this right now. And the first step, again, is labeling all the sides you can. Once you get 2 sides, you should be able to fill in the third side using the Pythagorean theorem. Cool. Down here, I just left some more space. I just realized I asked you already to graph cosine inverse. So I want you, don't worry about graphing cosine inverse, okay? We already graphed that up there, or you should have already graphed that. I just want you to graph tangent inverse, and we'll leave one of them blank for you to use another function in class when we get to class, okay? So graph tangent inverse. Remember, you have to restrict the domain, otherwise it won't work as a function, and graph that one, okay? Thank you very much.